We were threading some rods on this the other day, and actually they were for the mine too. These are for the mine. But the ones we threaded the other day were 1018 steel. So when we had our die set, since we're using 4140 now, quenched and tempered 4140, we got to crank the die down a little bit more because the pressure against it, it takes more to cut to the same diameter. So that's one little thing about threads. We did these ones here, and we got a few more that we're doing yet. We sometime back, this is the one, yeah, sometime back we're actually taking some 4140 and making, instead of cut threads, we were making rolled threads on it. And there are nicer thread rollers. This one is Soviet surplus, and we were rolling threads on hardened 4140. They were, and it worked out. It's a little bit tough to do. We did take some chunks out of the rollers, but you know, it's different. The steel you're working with makes a difference when you're cutting threads. One that I used to really like, and I've got some of the heads over here, one or two different ones, but I really haven't picked everything out because we haven't needed it for anything, but I'd love to have an assortment set out. I was thinking about buying, actually, another LANDIS threading machine that I know where is, but the old LANDIS system. And, well, I guess we could talk about the LANDIS threading system, even though we're not doing it here. This is some miscellaneous. These are geometric threading heads. These are real common ones that everybody used to use. And they're kind of like the pipe threader, except they were real common on turret lathes. You can use them on an engine lathe too. You can use them on a CNC. Very few people do because they want to keep it to where the changes from one part to the next are program changes instead of tooling changes. This requires tooling changes to change the thread. But this, even with your CNC, single point versus this is about 10 to 1, maybe 20 to 1 for speed. So if you're looking for speed, things that are chasing heads really speed it up. And that doesn't matter whether you're doing especially when you're looking at single point by hand, because the CNC for single point is not too bad. But single point by hand, chaser really, really beats it. These ones here, just like your pipe bolt cutters that we were using there, they have a cutting edge ground in here, and everything is cutting. Everything is cutting. There's a chamfer to start with, so it starts in cutting a little bit easy. Probably, instead of looking at that, should just pull out a die set. I don't feel like pulling that one out of the head. Let's just pull one out here. I bought that with a lot of spare dies. These are actually really inexpensive now because all kinds of shops that were using them have quit using them. And, oh, this is a really little delicate one. But anyway, it's all cutting surface here is the big point. I probably should have got a bigger one for the camera, which we're not an automotive shop. Oh, here's the other new Soviet thread roller. Since I liked the way the one worked so well, I bought a second one, knowing that I wasn't going to be able to buy replacement rollers for it. If we were doing a lot of thread rolling, we would buy Fayette, or there's two brands that really fight on that, but Fayette is the biggest standard. Okay, here's ones that are at least big enough to see. Yep. And so you can see it. All of this is sharp teeth. Have a little bit of a chamfer. And as these dull, since the cutting happens at the front of it, you keep sharpening it back. You grind this back in. Where I used to run a lot of turret lathes, we just used a standard everyday carbide grinder with a white wheel on it for grinding high-speed steel, and we had some little stops on there. We just clamped little pieces of high-speed steel, and you just grind this grind the front down. You grind this at a relief angle. You set your table at the angle you want, and we just hand grind it back and forth, and go back to cutting threads. And it's not that hard to sharpen them, but The thing about it is, the geometric style, all of the geometric style, your pipe threaders, all of those use cutting edge all the way around. What is so beautiful, and a lot of your high-end stuff really goes into, they're not going to be there anyway. Again, we moved that for automotive stuff. So the LANDIS stuff will be here too. This is a LANDIS head. This is a LANDIS head. We have got, yeah, we do that sometimes. Stack up. See, that's why a lot of the CNCs that we weren't using are going out, because we need room. You know, some people were like, well, what are you going to put in its place? We don't need to put anything in its place. We just need room. We just need room. I love buying tools, and I have overbought tools. It's just that simple. I have too many things, and it's becoming a mess. We need to have what we use. They're not my Subaru headers. I did Subaru years ago. I did Subaru Brat. And I actually kind of sad that I got rid of my Subaru Brat, because it was a really nice Subaru Brat that you don't see anymore. It was the last one I had was a 79. Yeah. Okay. Here is the thing, and these ones were ground wrong. Yeah, somebody here had only worked with geometric chasers, and they ground these wrong. They ground the cutting edge sharp. And if you grind the cutting edge sharp on these, especially since there's a lot of rake angle, your part will move around in here, and this will really cut terrible. That's not what you do with these. You go back here past the first full thread, and then you cut down. You grind down, depending on the size of the chaser, a 32nd to an 1/8 of an inch. You grind down. You make a step in these. And what that does, you adjust the cutting part so that it's on the center line. And then this part here that you did not grind down will be further up on the stock. So what it's doing is essentially you have got the front part of the step is coming in here at center line, and then the part of the die that's behind it, so it's got to cut a little bit to get on this motion, but the part that's behind it is above center line. So as you can see, it would be out here in space. And what that does, you always use these with oil. You don't want to use these with water soluble or thin. You want heavy, because it's high pressure cutting. This part out here is actually above center and just rides as a guide along the threads that you've already cut. And it does a combination of burnishing the threads a little bit and holding this in center. And they really make a nice thread and are super easy to sharpen. Because like the geometrics, where I said you can sharpen those on your carbide tooling grinder, you can sharpen them on a surface grinder, you can sharpen them on a lot of fixtures. These ones, you literally sharpen them by hand. They make a fixture for it, but most shops that run these, you just go over to the bench grinder and you sharpen it. As long as this part is lower than this part. If you go too low, it'll still work fine. If you don't go low enough, you learn quickly, you just go lower. The only problem with going lower is you wear out your dies quicker. You know, they go away quicker. If you go way lower too much, of course, this is going to hit this. So if we were working with a number 6 screw, really little ones, and I don't know if they even make heads that do number 6 screws. This is normally for bigger stuff. The smallest that I ever ran a LANDIS on was 1/4 inch threads. Normally, the machine I used to run the most that ran the LANDIS did 1/4 inch to 2 inch is what we did on it. The one I might make a call to a friend of mine that bought one many years ago. It's got dies. It probably does 1/4 inch also, but it was a 2.5 maximum on that one. He bought it really cheap. Felt bad when I found out that he bought it, because I wanted to buy it. I also know he hasn't used it since. So anyway, and we might not do that much threading again. Our work varies. We can get a whole bunch of one thing, and it could be the same thing for 5 years, and then you don't see it again, period. or something new. We're in an unknown area of what the work is right now. There's a few things coming in here and there, but we don't know what it is. There's nothing steady that's a repeat at this point. And anyway, that's the LANDIS system, and having that stability is a big benefit. Oh, another thing really cool with the LANDIS. If you're using the geometric head, you have the geometric head will switch. There's a pin you pull out, you switch it a little ways. It will do left-hand and right-hand threads, but you need left-hand and right-hand dies. With the LANDIS, you get different blocks. So, and your chaser is for a threads per inch or a metric pitch. They're for the size of the threads, the spacing between the threads. The diameter is irrelevant because that's all a matter of adjustment to get your diameter. So if you have a 16 pitch, you can do a half, well, which ones are 16? My mind's going blank right now. There's a quarter, 3/8 16. You can do a 7/16 16, I think. Yeah, I think those two. Anyway, you can do any of them that have the 16, or you could just plain like 12s. It's real common. You can do all of the 12s. If it's a 12 pitch, the diameter doesn't matter. You can make whatever you want on that same head. Where with the geometrics, you need ones, you can cheat them. It's labeled like you can use a 1/4 inch one. It'll go all the way up to 5/16 on a 3/4 inch head. It's not meant to do that, but most of the heads will go that far. You could go a long ways and do more than what they say, but they won't go from a 1/4 inch diameter to 2 inches all with the same chaser. That doesn't work. The other thing is, like these right here, these blocks that hold this, these ones are right-hand blocks. But on the same head, you pull these blocks off, use all your same chasers, you just turn them around, and you put them in a left-hand die block. And then with your left-hand die blocks, then you go left-hand without having to buy all different chasers, without having to buy a different head. The LANDIS system, it's miles ahead of the others for cut threads. Most of this stuff is for production threading. Production threading today is mostly done with rolling. Rolling is a whole different game. But the smaller shops or shorter terms of running things, cut threads are really common. Which brings to another point too, on this job here, the bolts that they had, these are replacement bolts, these are for liners for sag mill. And they don't really get a whole lot of pulling on them because they're just holding, and all the rocks, everything's beating in the same direction as the bolts. But they're going to tighten these down with a type of a mechanic's torque wrench that is really common in industry but not recognized as a torque wrench. It's called a 1-inch impact. And they will go thump, 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 thump. They probably won't go thump, 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 trying to break the bolt, but they will go thump, thump, thump. And the threads need to have some strength to them. So we could have technically used 1045 if it had proper heat treating. Nobody in Alaska stocks 1045, except for mine I used to work at, and that was annoying because they also stocked only 1045. But anyway, so we stepped up to the 4140 so that we could give them a better thread, because their original one was a 10, probably a 1045 or 1050 bolt that had rolled threads. So again, the same thing. Even if we did have the 1045, it was a little iffy since we were going to do cut threads. And I was not going to set up to do rolled threads for this quantity here. But with the quenched and tempered, already hardened 4140 with cut threads will be just as good as the grade 5 bolt that they had before, actually a little better. And so that's why we went with the harder stock on this. The job that we were doing before for them, same size stock, same thread, using the same pipe threader dies, And it was for a valve positioning rod. So for valve positioning rod, which they needed quite a few of those too, but for a valve positioning rod out of 1018 was just fine. All it was is positioning rod. It didn't have any load that would ever be on it. But anyway, that was why, because we're doing cut threads, is why we swapped to the tougher material, alloyed material.